So in example number 3, remember I said for these optimization problems, they're going to give you a bunch of information. You're going to have to write down some sort of equation or function. And then to find the minimum or maximum value of that function, you take the derivative, set it equal to 0. That gives you a bunch of x's, and then you pick out which x works. So let me read example number 3. It says an open top box is made by cutting congruent squares of side length x from the corners of a 20 by 25 inch sheet of tin, and then bending the sides up. How large should the squares be to make the box hold as much as possible? What is the resulting maximum value? So what we're trying to do is we are going to have a rectangle that is 20 by 25, I think it was, right? Yep. And this is inches. And so what they want to do is they want you to cut out 4 congruent corners. Okay? And then fold those sides up and that makes your box. So you're going to have an open top box. And so when you're done, your open top box will sort of look like this. Does that make sense?
Mm-hmm.
And they want to know how big these squares have to be. Well, I'd like to know how big those squares have to be. So, what's this length from, say, here to here? Anybody know?
X.
Yeah, when we don't know, it's x, right? And if they're congruent squares, that means that this length is x.
Mm-hmm.
And if it's a square, that means that this length is x. And this length is x. So when they say holds the most amount or the maximum amount, what are they talking about this box?
Has no volume.
When they say hold, they want to know the maximum volume. Volume of a box is the equation we need to write. So the volume of the box, isn't that length times width times height?
Yep.
Am I close?
I think so.
All right. Well, we're halfway done. What is the length of this thing? Well, if I say that this is the width, and I say this is the length, and from here to here is the height, the length, what is that? That's this part right here, right?
25 minus 2x.
Thank you. 25 minus 2x. What would the width be then?
20 minus 2x.
20 minus 2x. And then what would the height be?
X.
X. Good. So, wow, this is really easy. So if I say the volume of the box as a function of x, I would say 25 minus 2x times 20 minus 2x times x. Right? How do I find the maximum value? I was going to say volume, but I switched mid-word. How do I find the maximum value of this function? Plug it in the calculator.
Take y prime. So
Oh yeah, you can find
Yeah, we could take y prime. Okay. Now, if we to save time, you guys already know how to multiply that out, right? I don't have to reteach you how to multiply it out. If I expand this and I multiply this through the parentheses, and then that'll give me a product, and then I multiply it through. When I'm done, v to the x is actually x cubed. Oh, it's actually 4x cubed minus 90x squared plus 500x. Okay? Now the reason I multiplied that out is because it'd be a lot easier for me to just do the algebra and multiply that out and then take the derivative of a polynomial. If I try to take the derivative of this thing right now, I gotta use like the product rule and then the product rule with the product rule. It's just easier to make it a polynomial. Does that make sense? So now what do I do? I need v prime. So v prime is equal to 12x squared minus 180x plus 500. So far, so good. And what do I need to find for that equation?
Set equal to 0.
Set equal to 0. Now, I don't think that's factorable, and even if it is, 500 is a really big number. What's the quick, easy way to find the zeros for this function?
Plug it in.
Plug it in the calculator. Now, do I plug this in the quadratic formula in the calculator, or is there a quicker, easier way? Graph it. So what I'm going to do is I'm going to plug that equation into my graphing calculator as soon as I put my marker back here. Alright, so I come in here and I clear this out, and what was that? It was
12x squared
12x squared
minus 180x.
180x plus 500, right?
Yeah.
Alright, so I gotta erase that. That's from the other class. I gotta set the window so it kind of fits. So I want to go from 0 to 10. Now I'm suspecting that my y value should be between -1 and 0. I'm thinking that there will be 1 0 somewhere in there, right? And I think the other thing that I had a problem why my calculator was messing up is that on my previous class I started at 4,000. I'm going to start at 0, okay? And I'm going to count by ones. We'll count by 0.1. All right, so now when I graph it, I should have a little bit of help. Oh, wait, let's check that one more time. So,
Great, you brought me
now, I want to go to 1. Sorry, I got trying to talk and teach. So I'm going to go from -1 to 1 on the y values, okay? So I think that graph will cross one time. What does that look like? 3 point something, right? So now here, what I'm going to do is I'm going to hit second trace to calculate my 0. And I'm going to go a little bit to the left of that, which is like 3 point something.
8.
I think you're going down.
And it's really kind of, we've really zoomed in on it. So what I'm looking for is I'm looking for when this is a positive value. Or I'm sorry, a negative value, or when it's close to 0. See how I'm getting close? Okay, boom, that's good enough. And then I got to do this one, that's good enough. Come back, guess. Where does that occur? 3.68.
Guess that.
How did I guess that?
You're like, that's probably 3 point something.
Oh, how did I know that? 1, 2, 3, 4.
No, like where it's.
I'm a wizard. You know what's funny? Like when I say that stuff, you're like, oh, why didn't I think of that? That's why they call me the wizard, right? It's because, but you know, Mr. Adams is a math teacher. I've probably explained this problem half a dozen times. So, but yeah, that's the answer. So what does that tell me? It tells me that if I let x approximately be 3.68, that will give me the maximum value. Well, what was that maximum value? Well, I've got to plug that in to this equation. So for my last step, what I'm going to do is I'm going to say 25 minus 2 times 3.68 times, in parentheses, 20 minus 2 times 3.68 times what? 3.68. 820.5 units. Let's see what the book says.
You're right.
Yep.
Yeah.
Now, it had, your textbook went, and I kind of said the same thing. It had another solution at 11, but we can't choose 11 because it's too large of a number. Thank you, and have a good day. Well, the bell rang. I don't know what else to say. Bye.